Hi there. In Chapter 7, we'll be looking at simplifying expressions using the exponent rules. Today we're going to be looking at two exponent rules in Lesson 7.1, the zero and the negative exponent rule. First, let's take a look at the zero exponent rule. In order to figure out what any number to the zero power is, let's take a look at a pattern that we see in some of these numbers. So we know that this big number is the base, and then the smaller number here is the exponent. Remember that a power like this, 2 to the third power, is just a shorthand way of writing a multiplication problem. This is the same as saying 2 times 2 times 2. So we know 2 times 2 times 2 is 8. 2 times 2 is 4. 2 to the first power is 2. And now if we take a look at this pattern, and if we were to continue it, what would 2 to the 0 power be? Well, take a look here. Every time I look at another number in the pattern, I'm dividing by 2. So if I keep that going and continue dividing by 2, 2 divided by 2 would be 1. And here I have 2 to the 0 power is equal to 1. Now you can try that on your calculator. Type in 2 to the 0 power, and you'll see it's equal to 1. Let's look at another pattern. 3 to the third power is the same as going 3 times 3 times 3. 3 times 3, and 3 to the first power is 3. So if you look at the pattern here in the numbers, you're dividing by 3 to get to the next number. So if we continue the pattern, 3 divided by 3 is 1. So that makes 3 to the 0 power also 1. Try typing in any number to the 0 power in your calculator. Pick your favorite number. My favorite number is 14. So if I type in 14 to the 0 power, my calculator will say 1. Let's see if I can do it and you can see what's happening here. If I go 14 and raise it up to the 0 power, not sure if you can see that or not, but the answer is 1. Any number to the 0 power is 1. So we can write that any number a to the 0 power is equal to 1. Any number to the 0 power is equal to 1. Now there is one exception to that. 0 to the 0 power is not equal to 1, but for what we do in math here in 8th grade, any number taken to the 0 power is going to be always equal to 1. Okay, so there's our zero exponent rule. Now let's take a look at some examples where we are going to simplify. Again, if you haven't tried this in a calculator, do it. We have negative 4 to the 0 power. That's going to be 1. Now let's jump down here. This says 1 divided by 7 to the 0 power. 1 divided by, now we know 7 to the 0 power is 1. So 1 divided by 1 is 1. So I get the answer of 1 for here and for here. Now let's take a look at this, because this one's different. Now I have 5 stuck to the end. They're stuck together with an invisible multiplication. So this is 5 times n to the 0. Well, we know that any number to the 0 power is 1. So this is the same as 5 times 1, which is equal to 5. So this one's just a little bit different. So there we have it. We simplified using the zero exponent rule. Okay, I guess I'm getting excited for the next one. Let's take a look at something called the negative exponent rule. When you're simplifying expressions, you don't want to leave anything to a negative power or a negative exponent. You always want to simplify it. So let's take a look at some patterns before we start simplifying using a negative exponent. So remember the pattern that we were looking at before? 2 to the third power, right? 8, 4, 2, and then 2 to the 0 power is 1. Let's continue that pattern. Remember, it was dividing by 2 to get to the next number. So if I continue that pattern, 1 divided by 2 would be 1/2. So 2 to the negative first power is 1/2. 2 to the negative second power would be 1/4, because again, I divided by 2. And if I divide by 2 again, I get 1/8. Oh, okay, that looks pretty good. Let's go over here and try this one. Again, remember that we're dividing by 3 to get to the next number. So 3 to the 0 power is 1. 3 to the negative first power, well, I'd take the 1 and divide it by 3. 1 divided by 3 is 1/3. Then divide by 3 again, 1/9, and again, 1/27. All right, what I want you to focus on in this is, let's look at 2 to the third power is 8, and 2 to the negative third power is 1/8. Now look over here. 3 to the second power is 9, and 3 to the negative second power is 1 over 9. Do you notice anything about these two? They're reciprocals of each other, aren't they? Same thing here. 3 to the second power is 9 over 1, and 3 to the negative second power is 1 over 9. They're reciprocals. Well, what I want to take a look at right now is, let's see this 2 to the negative third power. Remember, it's 1/8. So if I have 2 to the negative third power, and if I want to evaluate that without a calculator, I can take 2 to the negative third power and write it as a fraction over 1. Now, in order to evaluate this without a calculator, if there's a negative exponent, I want to notice that that negative exponent is upstairs, up here in the numerator. If I move it down to the denominator, the base stays the same, the 2, but the exponent becomes positive. Now, what would be left in the numerator? A 1. So these kind of look like reciprocals of each other, don't they? Now I can evaluate. 1 over 2 times 2 times 2 is 8. So here I see that I started with 2 to the negative third power, and I end up as 1 over 8. So 2 to the negative third power is 1/8. And we all saw that over here in the pattern. And if you used a calculator, you can see that too. So our goal here is to be able to take a negative exponent like this one and simplify it without using a calculator. Okay? We want to take the negative exponent and make it positive. All right, so let's give this a try. So I have these 3 examples. Okay, this one is just a generic expression here. We have any number a to the negative n power. So we want to simplify this, and obviously we couldn't use a calculator for it because we couldn't plug in letters into a calculator. So my goal to simplify this is to undo this negative exponent. I can't have a negative exponent. So the first thing I would want to do is write this number here as a fraction. And to write any number as a fraction, like if you have the number 5 as a fraction, it's 5 over 1. If you have the number 17 as a fraction, it's 17 over 1. So I can take this number right here and write it as a fraction over 1. Now, do you notice here how the negative exponent is upstairs, up in the numerator? To make the exponent positive, I want to move this power downstairs. So I'm going to move it downstairs, down here. The base stays the same, the big A stays the same, but the exponent becomes positive. Now, what's left in the numerator? It would be a 1, because think about this. I could add a 1 times a to the negative second power, and it wouldn't change this. So we can say that a 1 is left up in the numerator. Now, there isn't anything to simplify. I'm done here. I've gotten the negative exponent to become positive. If I look at the next one, here 4 to the negative third. If you see a negative exponent, make it a fraction over 1. Now I need to take this power and move it downstairs. See how it's upstairs in the numerator? We move it downstairs. The base stays the same, the big 4, but the exponent becomes positive. Again, there's a 1 in the numerator, but I can keep going with this one. 4 times 4 times 4, 64. And I'm finished. If I typed in 4 to the negative third into a calculator, the answer would be 1 over 64. Okay, now let's take a look at this one. Again, negative exponent, so I'm going to make it a fraction over 1. I see it's upstairs, so I'm going to move it downstairs. Now, the base stays the same, so the negative 2 will stay the same. The only thing that changes is the exponent. It's now positive. So 1 over negative 2 cubed. Okay, let's simplify. 1 over, now here, negative 2 to the third power. I take 2 to the third power. 2 times 2 times 2, which is 8. And then the negative goes in front. Okay, again, you can think of this as negative 1 times 2 to the third power. We first do the exponent, and then we pull the negative in front. Okay, so if I typed in negative 2 to the negative third power, the answer in the calculator would be negative 1/8. Pretty cool. So let's take a look here. A negative exponent in the numerator will move downstairs. Okay, that way it will, become positive. All right, so we're going to put downstairs right there. Now let's take a look at a few more examples. Again, using the negative exponent rule. We want to simplify this expression because we see there's a negative exponent. You can't have that. So where is it located? Do you see here it's downstairs in the denominator? So I'm going to move it upstairs to the numerator. The base stays the same, but the exponent changes to positive. Now, of course, I could write that over 1, but I don't need to. Here's my answer. 1 over x to the negative third is the same as x to the third. Okay, I've just moved it upstairs. All right, let's take a look at this next one. Here I have 2 over n to the negative fourth. So because n to the negative fourth is the negative exponent, this one's going to have to move. Now 2 has a positive exponent of 1. It gets to stay where it is. So if I were to rewrite this, in the numerator, the 2 gets to stay where it is. But the n to the negative fourth is going to have to go upstairs to join the 2. So I write it up here. The base stays the same, but the negative 4 exponent will become positive. Now, of course, down here in the denominator, there would just be a 1. So I really only need to have 2 n to the fourth power. So do you see how the negative exponent moved upstairs along with the 2? And there's my simplified answer. Last one here. I have a negative exponent, and this is in the denominator. So I'm going to have to move this upstairs because it's downstairs right now. Remember, the base stays the same. So the negative a stays the same. Just the negative 2 exponent will become positive 2. And then, of course, because a isn't a number, this is in simplest form. Okay? So let's just review here. If a negative exponent is in the numerator, it will move downstairs. A negative exponent that's in the denominator will move upstairs. And the, you guessed it, base stays the same. All right. Now we're going to just try a few more here with the negative exponents. I have 3 to the negative fourth. Again, if it's not a fraction, write it as a fraction. Then you can see that this is upstairs. Where's it going to move? You're right, downstairs. The base stays the same. Exponent becomes positive. In the numerator, there's a 1. Keep going. 3 times 3 times 3 times 3, 81. And I'm done. 3 to the negative fourth power is the same as 1 over 81. Next one. Negative exponent downstairs in the denominator. Let's move it upstairs. The base stays the same. Negative 4 stays the same, but the negative 2 exponent becomes positive. Remember, this is upstairs, so down below there'd be a over 1, but we don't need to write that. Now let's evaluate. This says the opposite of 4 squared. 4 squared is 16. The opposite of that is negative 16. Now it's important that you realize the difference here. This is negative 4 squared. It is different than if I had negative 4 in the parentheses and squared it. This says the opposite of 4 squared. I do 4 squared first and get 16 and then bring the negative in front of it. It's kind of like a little negative 1 being multiplied by 4 squared. I do the exponent first, get the 16, and then bring the negative in front. Now this one says negative 4 to the second power. Negative 4 times negative 4. The entire negative 4 multiplied by itself twice. That's positive 16. So these two are different. You got to know the difference between these two. So when I simplified over here, this says the opposite of 4 squared. All right, so negative 16. All right, then the next one here. Negative 5 to the negative third power. I'd write it as a fraction. That way I can see that this is upstairs. It has a negative exponent, so it's going to move downstairs. The base stays the same. The negative 5 will stay the same. The exponent becomes positive, right? And then because it's downstairs, we need a numerator. If there's no numerator, it's 1. Keep evaluating. Negative 5 times negative 5 times negative 5. That's negative 125. So if I typed in negative 5 to the negative third power in the calculator, it would tell me this right here. Okay? So a negative exponent in the numerator will move downstairs. A negative exponent in the denominator will move upstairs. And the base stays the same. All right, very good. Now we're ready for some examples. Now what you're going to see here is an expression. And you're going to be asked to simplify it with exponents, zero exponents, and negative exponents. So our goal is to simplify this as much as we can using our exponent rules. Now I want you to think of this expression as every single term being multiplied together. Because the 4 is stuck to the A, stuck to the B, stuck to the C, There's invisible multiplication in between every single one. Do you notice how this isn't a fraction and we have a negative exponent? Let's make it a fraction by writing it over 1. Now, we need to decide how to simplify this. Looks like we're multiplying c to the 0 power. We know that anytime we have a number to the 0 power, it's 1. So think about if I change this to a 1. If I multiply by 1, it doesn't change anything. It's almost like this disappears. Multiplying by 1 does not affect anything. So I can just change this to a 1 and not worry about it. Now the 4 stays where it is because it has an exponent of 1. You just don't see it. The b gets to stay where it is. Who has to move? You're right, this guy is going to move downstairs. So let's write the fraction again. 4 stays in the numerator. The b stays in the numerator. But the a to the negative third moves downstairs and becomes a to the positive third. And I have simplified it. Notice that the c to the 0 just goes away. And here's my answer. My answer only has one b and one a in it. Everything has positive exponents. Let's try the next one. Now I have a fraction here. These two are multiplied together, x, y, z. Okay. Looks like this one has a negative exponent. It's going to have to move downstairs. Do you see this one in the denominator? This has a negative exponent. It's going to have to move upstairs, isn't it? So let's rewrite this. The x to the 6th stays where it is. The y to the negative first moves downstairs and becomes y to the positive first. We don't need to write that, though. The z to the negative 4th moves upstairs and becomes positive. So these two just switched places, didn't they? And here I have x, y, z. Everything has a positive exponent. Done. Number 3. Here we're asked, what is the value of this expression? And I'm asking you to plug in a number for m and a number for n, and I will give you those numbers in just a moment. Okay, what I would do here first is to take a look at the expression and see if you can simplify it first. So remember, all of these are multiplied together. I'm going to write it as a fraction over 1. Looks like we have a negative exponent. This one's going to have to move downstairs to become a positive exponent. So negative 7 and n to the 3rd stay in the numerator where they are, but the m is going to come downstairs. Okay, now that I have everything turned to positive exponents, now I'm going to start plugging in. M, I will tell you, is negative 4, and n is 2. Now let's plug in or substitute m and n right in here into the expression and find the value of it. So remember, these two are multiplied together. So I have negative 7 times n to the 3rd power all over m to the 3rd power. I'm going to put in parentheses for n and m because I'm going to be substituting a number in there. So n is 2 and m is negative 4. All right, then we're just going to go ahead and evaluate. Remember, you're multiplying up here. So I have negative 7 times 2 times 2 times 2, 8. And then down here, I have negative 4 to the 3rd power. Negative 4 times negative 4 times negative 4, negative 64. Now let's drop this down here. Negative 7 times 8 is negative 56. We have a negative divided by a negative. That makes a positive. So I'm going to go positive 56 over 64. And then take a look at these two and see, can you simplify? Sure, you can divide by 8. And then you get 7 over 8, 7/8. So if I took this expression and simplified it and then plugged in m and n here and evaluated, I would get 7/8. Let's look at number 4. Again, here I have an expression that needs to be simplified because of the negative exponent. So remember, they're all multiplied together. Make a fraction. Okay, so the x to the negative 2nd power is going to move downstairs. So I'll have 2 y to the 4th over x to the 2nd. Now that I have that, I'm going to substitute negative 2 for x and positive 1 for y into my expression. So x is negative 2 and y is positive 1. So it looks like here up in the numerator, exponent 1 times 1 times 1 times 1 is 1 times 2. And then here I have negative 2 to the 2nd power, negative 2 times negative 2, 4. that would simplify to 1/2. So again, I took the expression, simplified it, then substituted in the numbers, and found the value. There's number 4. All right, number 5 and 6, we just have 2 expressions here that we're just going to simplify using our exponent rules. Right now, they might look a little bit intimidating, but really they're not. We're just going to take them one step at a time and start simplifying. So everything's being multiplied together. Just want to remind us about that. I see a to the 0. Anytime I see a 0 exponent, I'm just going to change it to a 1. Remember, if you're multiplying by 1 here, that's not going to change anything. It's kind of like it cancels out. Okay, let's start. This says -5 to the 2nd power. That's the opposite of 5 squared. Remember, you do 5 squared first because this isn't in parentheses. 5 squared is 25, so -25. Now the b. The b has a negative exponent, so we're going to move it downstairs and make it a positive exponent. Moving it downstairs right away. Now I have a c. The c is just fine where it is. Okay, so we're going to leave it up here. So I've dealt with everything in the top. I did this, I did this, I did this, and I did this. Now let's go down here. Do you see the 5? The 5 gets to stay where it is. It has a positive exponent. So I'm going to write the 5 down here. And now the d. Do you notice the d here has a negative exponent? It's going to have to move up, isn't it? So I'm going to put it upstairs with a positive exponent. Now take a look at what you have. I have a c, b, and a d. They all have positive exponents. However, this right here, this can be simplified. -25 divided by 5. -25 divided by 5 is -5. Remember, you'd write -5 over 1 if you were to write the number -5. So -5 goes up here. And then we'll just copy everything else down, all of these. And done. All simplified. See, not too bad. Looked scary, but it's not bad. Let's try this one. Okay. All right, q to the 0 power, cancel. I'm going to draw a fraction here. All right, 2 in the numerator gets to stay. P to the -5th, move it downstairs. So I've dealt with everything up here. Now let's go down here. -4 to the -2nd power. It has a negative exponent, so I'm going to have to move it upstairs. Now remember, the base stays the same. The -4 stays the same. The exponent becomes positive. Okay, dealt with that one. R to the -1st. Well, it has a negative exponent, so I'm going to have to move it upstairs, up here. +1. Again, you don't need to write that. Now, it looks like we still have some simplifying to do. Remember, everything's being multiplied together. So I can evaluate -4 to the 2nd power. -4 times -4 is 16. And then 2 times 16, I get a 32, and that's in the numerator. So 32 up top, along with the R. But then down here we had a p to the 5th. Simplified. Done. See? Not so bad. Now, if you look in your notes at number 7, I think in class here we're going to be skipping number 7, so I'm not going to go through that one. But let's just go right to the summary. So the 2 exponent rules we looked at today was the 0 exponent rule and the negative exponent rule. So we want to assume that any number to the 0 power is equal to 1. Always. We're just going to assume that any number, so you can write 5 to the 0 power is 1, -4 to the 0 power is 1. Anything to the 0 power we have is 1. Okay? So even if I had the number 1/2 to the 0 power, it's going to be 1. All right? Always assuming that that's the case, simplifying it like that. Then the negative exponent rule. To make a negative exponent change to positive, we move it up or down, upstairs or downstairs. You move it up or down, and it makes it positive. But remember, the base stays the same. So there's our 2 exponent rules for today. Have a great day. Thanks.